Okay, Assalamualaikum warahmatullahi wabarakatuh to all brothers and sisters. So now let's continue on the bipolar junction transistor introduction. So now we move forward to the equation, the basic equation of your BJT transistor. So this is the symbol of your BJT transistor. So we have B, C and E. So at the 3 point of your BJT, we have 3 current. One we call IB, entering IC and IE. So between B to E, we have a diode. So means if we draw the physics here, so this is N, P and N. Here is your emitter, here is your base, and here is your collector. So between B and E, you have one PN junction that is a diode. So recall back, what is the equation of the diode current? So ID for a diode to work. So ID equal IS reverse bias saturation current equal exponent VD over VT thermal voltage minus 1. Okay. So if you use this equation of your diode, since between B to E is your diode, so how you are going to change your ID? So instead of ID, now it become IE. So your IE will be equal to your ISE. Now instead of diode voltage, now between B to E, we have one voltage what we call VBE. So we can equate your VBE here for your BJT is like your V gamma, your turn on voltage of your BJT. So usually your VBE here is 0.7 volt. So your VBE need to be more than 0.7 in order for you to turn on your BJT. So here become VBE divided by VT minus 1. So you can ignore minus 1, so it become IS equal VE, VBE over VT. So what is VT here? VT is the thermal voltage, where if it is a room temperature, the VT will be 0.026. Okay, now so let's continue on the second equation. So the first equation just now is your IE. So the second equation is your KCL equation. So based on the figure shown here, so we have NPN. So you imagine this one is like a junction. So what is the current entering the junction? Is your IC and your IB. What is the current leaving the junction? Is your IE. So remember, if your electron movement towards your right, so your current will be in the opposite direction. So in this case, for your NPN, the movement here is electron. That's why your current is at the opposite side. So what is the current entering the junction? The whole junction is your IC plus IB. How about the current leaving the junction? Is your IE. So leaving the junction is your IE. So you can get the second equation of your BJT, IE equal IC plus IB. So now let's go to the third equation. So your third equation here is your relation between IC and IB. So take note again, for your physics of your semiconductor, here is N, P is lightly doped, N is highly doped. So here is your emitter, here is your base, and here is your collector. So most of the electron will move forward from emitter towards your collector. So your only 2% will go down to your base, 98% will move towards your collector. So how you're going to find the relation between IC and IB? So at your base, only 2% of the electron will go down. So you are expecting here your IB is become very, very, very small. That is towards the microampere. So your IC will be equate to beta IB. Now what is beta? Beta is the gain, common emitter current gain. So why we call gain here? Because your IB is very small, right? Milliampere. So your IC will be much more larger than your IB. Usually the unit is milliampere. So you will need to get the gain more than 1. So let's say maybe the value of your gain can be 100, 50, any value more than 1, 20 or others. So there is a gain of current happen here where your IC will be equal to beta IB. So beta is the common emitter current gain. Okay, now so for the fourth equation, we're going to relate between IC and IE. So where is your IC? IC is at your collector part. Your IE is at your emitter part. So you know from the second equation, your IE, current entering, equal current leaving. So from the previous equation, since there are only 2% going down, so your IB will be around microampere. So your IC will be much more larger than your IB, that is milliampere. So again, your IE here also will become milliampere. So how we're going to equate IC and IE? So your IC and IE, since your IB here is very small, milliampere, so you can equate your IE almost the same. Almost the same because IB will not affect directly to the value of IE and IC. Why? Because only 2% will go down of the electron will go down to your base. So you have another denotation here what we call alpha. So your alpha value will be ideally will be equal to 1. So if your IC is milliampere, your IE will also be milliampere. But in reality, it becomes 0.9 or 0.998. So just now, your beta value must be more than 1 because it is a gain. Your alpha will be must be almost 1 because your IC will be equal to your IE. Okay, so now the basic equation of your BJT is number 1. IE equal IC plus IB. Number 2, IC equal beta IB. So beta must be more than 1. The third equation is IC equal alpha IE where alpha must be almost 1. So what you need to do now is the derived equation. So from these three equations, you need to derive to show that what is the relation between alpha and beta. So the first one is alpha equal beta over beta plus 1. Okay, so I give you some time to try by yourself to derive how from these three equations you can prove that alpha equal beta over beta plus 1. So this is a example of how to derive. So you can use your own way. Either you want to plug in 2 into 1 or 3 into 2. As long as you can derive that, your alpha equal beta over beta plus 1. So your alpha will be, the name is common base current gain, and your beta is common emitter current gain, and your alpha is common base current gain. So which one will be more than 1? Your beta will be more than 1. Your alpha must be almost 1. Okay? Thank you.